A tuna going 2.35 meters per second accelerates at that rate, covering a distance of 45 meters. What time did it take? So let's see, this is 45 meters. The initial velocity is 2.35. Final velocity, we don't know, right? Acceleration is 0.208, and we want to find the time, right? Okay. Now this one's also tricky. I'm going to recommend that we don't do it using no v, because that'll be quadratic. No v is this guy. Right. This leads to 45 equals 2.35 times t, which we're trying to solve for, plus 1/2 0.208 t squared. Now, if you look at this expression in the box, notice that it has t to the 0, t to the 1, t to the 2. This is quadratic, right? And so we'd have to use what the opposite of b plus or minus the square root of b squared minus 4ac over 2a and get the answer and choose the root. Let me suggest that we just say no. Okay, now I'll go back to the quadratic equation to show you that it can be done. Okay, but let's just say no. I'm not going to do that. I'm just going to solve for the final velocity first, and then I'm going to solve for t. So let's use, I guess, no t to find v. Is that right? Okay, so no t is v squared is u squared plus 2as. And that becomes v squared equals 2.35 squared plus 2 times 0.208 times 45. Okay, so it's going to be the square root of 2.35 squared plus 2 times 0.208. Now, if you're looking at this and this looks a lot like b squared minus 4ac, yeah, we're doing the same math, only we're just rationalizing it or something, I don't know. Okay, so this final velocity is 4.92366. All right, so now I can use v is u plus at and solve for t. That becomes 4.92366. I don't want to round that number because it's not like given to me, right? Is equal to 2.35 plus 0.208 times t. Okay, so I'm going to go that minus 2.35 divided by 0.208, and I get 12.37 seconds. Or 12.4 seconds, right, with 2 sig figs, right? Now, you can just stop here, right? That's fine. The question is, what if we did this with the quadratic equation? What would happen? So I'm going to just erase all this and go do the quadratic equation. So this is 45. The initial velocity is 2.35. Acceleration is 0.208. Right, and we want to find time, and we don't want to do 2 steps. We feel like we're not afraid of the quadratic equation. So we plug the numbers into s is ut plus 1/2 at squared, right? And we go 45 equals 2.35 t plus 1/2 0.208 t squared, right? And then this, let's see, let's rewrite this. So half of 0.208 is 0.104. I had to do with my calculator because I'm kind of spacey. So I'm going to rewrite this way. I'm going to go 0.104 t squared plus 2.35 t minus 45 is 0, right? Because remember, you have to write it equals 0 to use the quadratic, right? This becomes our value of a. This is our value of b. This is our value of c, right? Oops, that's not a bracket, right? And what is it? It's the opposite of b plus or minus the square root of b squared is it minus 4ac all over 2a? I think it's minus. Yeah. Is that right? I think so. We'll find out, won't we? Okay, so that translates into what? Minus 2.35 plus or minus the square root of 2.35 squared minus 4. A is 0.104. C is minus 45, right? And then that's all divided by 2a, which is 2 times 0.104. Let's see, we'll find out, right? Okay, so now I'm going on my calculator. The opposite of 2.35, I'm going to go plus square root of 2.35 squared minus 4 times 0.104 times negative 45, all divided by 2 times 0.104. And this is the plus answer, is 12.37. Okay, so the first answer I get is 12.37. And now let me do the answer. I'm going to go second entry. Let me change that plus to a minus. The other possibility is that it's minus, this is a minus. And I get negative 34.96, right? So it either happened before now, right, or it happened 12.37 seconds in the future. I choose the answer that makes sense. All right, so it's up to you. If you're not afraid of the quadratic equation, or you have software that does it for you, just barge right ahead and you can solve for it in one step. Most people find it easier to use no t to find v and then solve for t. Okay.